Greetings and welcome to this joint DCMI ASIST webinar. I'm Tom Baker, a member of the DCMI Directorate. This webinar is one in a series of joint DCMI ASIST webinars which are presented as a service to members of DCMI and ASIST and to other interested members of the public. The purpose of the joint series is to advance the discourse and practices of innovative metadata. You will have an opportunity to ask the presenter questions near the close of the webinar. There is a panel on the right of your screen to enter the text of your questions. We ask that you wait to enter your text until near the end of the webinar. I'll keep an eye on that channel and I'll moderate the questions and answers and pose them to our presenter. We'll address as many questions as our time allows. Our presenter today is Dave Clark. He's the co-founder and CEO of Synaptica group of companies, providers of enterprise software solutions for knowledge organization and discovery. He leads research and development at Synaptica and is developing an extensive range of software solutions for ontology management, image management, linked data management, and text analytics. He's actively involved in educational outreach programs, including LD4PE, which he'll mention later in his talk, the Linked Data for Professional Education initiative of DCMI. With that, I'll pass the microphone to Dave.
Okay, thank you very much, Tom. Good morning or afternoon, wherever you are in the world. I'm dialed in from the UK today. The agenda I've sketched out for this hour is I'm going to start with a little description about what linked data is and why it's good for you. I'm going to move in then on to explain our use case. So I'm going to focus on one particular application in this discussion. So I shall explain about our use case, which is an educational application built with linked data. Then I'm going to go into the design architecture and using ontologies as part of the design architecture for building applications. I'm going to talk about, fourthly, open data and reusing and adopting open data sources, including rich vocabularies and databases that are available as linked data. The next thing I'm going to do is walk through the user experience of an application. So this talk is titled Building Applications or Semantic Applications with Linked Data. So I'm going to give you a bit of an end-to-end end user experience of an application we've built entirely using linked data. Sixth and last, I'm going to talk a little bit about graph databases, relational databases, and different types of graph databases, RDF and non-RDF, and some of the performance considerations. So that should take us about up to the hour, and then we will have about 10 minutes for Q&A. So firstly, linked data, what is it and why is it good for you? So let's start with the world before linked data. Before linked data, data lived in fortresses. It was locked up inside proprietary databases, each of which used custom database schema, and every database record was accessed by identifiers that only made sense inside the system in which they resided. Very often the culture of this world was not for sharing, it was for firewalled privacy. And if data had to be shared at all, then it required the sharing of schema and UID keys, etc., in order to make sense. That was the pre-linked data world. In the linked data world, data is designed for sharing. It doesn't have to be shared, which I'll get to, but it's designed for sharing. So every resource has not a UID in an individual database scheme, but a URI, a universal record identifier, that has an HTTP address, and you can access these resources through HTTP wherever they are in the world and whoever's publishing them. So in the examples here, I could go to a medical record in the mesh vocabulary. I could go to Getty, Art and Architecture. I could go to the Library of Congress. I could go to geonames, etc. So these resources are openly accessible and shareable. The vision of this it was described by Tim Berners-Lee as turning the World Wide Web into a worldwide database, semantic web. So that's really what this is about. Now, in linked data, the links themselves are very, very important. In regular web links, they're simply a poster, a signpost, and they say, go over here, there's some interesting content. Linked data links are very different. Linked data links are semantic in nature. And what that means is they are semantically expressive. They don't just say, go over there, there's some interesting content. They tell you why bit of content A is linked to bit of content B, and they do so through relationship types that you can that can be looked up themselves. So they describe the very precise semantic nature of the link between any two entities. So links.
The broadcast is now starting. All attendees are in listen-only mode.
Okay, that was a little interruption there. Just to repeat, these links are all semantically expressed. So they don't just say go over here and look at some content. They explain why the content is relevant. There is something called the 5-star scheme for linked open data and for open data, and this basically walks you through an added value chain from 1 star, which is it's on the web, to 2 star, it's machine readable on the web, to 3 star, it's in a non-proprietary format. 4 stars uses RDF and Sparkle, which is the W3C standards, and 5 star is it's open and it links to other open data. So there are some pros and cons here to using linked open data as opposed to enterprise data. Linked open data, all linked data is basically capable of being shared, but linked enterprise data is just linked, structurally the same as linked open data, but it's data that can sit behind a firewall. I like to point this out because I believe that linked data as a data format is beneficial for all enterprises, whether your data is behind the firewall or whether your data is publicly shared. There are advantages to working in the linked data format in terms of the intelligence you can get out of data, the ability to pull in external data, mash it up, as well as publish it. But if you want to start off cautiously, there's nothing to stop you using linked data, building linked data databases within the enterprise and keeping them behind the firewall until such time as you want to share parts of them with the outside world. Okay. I'm going to talk a little bit about our use case now. So this is an end user application that's built entirely with linked data, and the application is an art history educational application. So in art history you need very often to look at visual material as well as textual material. And the study involves close looking at images, understanding the parts of an image, commenting on images and parts of images, and relating them together. And we thought that was a great use case for building an application out of linked data where there's a growing amount of resource and material, both visual and textual, on the web as linked open data. And the application we're going to look at today uses that. In art history there is a work, a reference work, which I've certainly used, and it's Erwin Panofsky's Studies in Iconology text, and it's basically a handbook, if you like, a manual of the interpretation of iconographic images. And Panofsky runs through a three-stage study, a three-stage process. Stage one is a natural analysis. You're looking at visual evidence and you're simply describing what you see, the objects, the colors, the visual evidence, unfiltered. Secondly comes an analysis called conventional analysis, and this is really interpreting what you see, the symbolism, the illusions and the ideas behind the visual evidence. And thirdly comes an intrinsic analysis in the Panofsky process, and this is understanding things in a wider cultural context. How does this particular work of art fit into history, into society and culture and so forth? Looking at that process and trying to model that as a business application, we have in stage one a representational process, in stage two a conceptual process, and in stage three a contextual process. So what we tried to do was build software tools that support those three processes. The first one is image annotation. It is simply bringing up an image and being able to annotate it, draw a square around an area of interest or drop a pin on an area of interest and describe that visual artifact. The second process, the Panofsky process, is supported through the process of semantic indexing. It's taking a visual artifact on the image and saying, what is it about in conceptual terms, in conceptual language? The third and final area is actually searching across collections, building knowledge graphs, and understanding a work in the wider context of information that's outside of the image. So those are the three processes in a Panofsky analysis, and we've tried to model those in the application that we've built. And we'll see how well or otherwise we've done as we go through that application. So from the general use case, we abstracted the following user requirements which we're trying to support in the application. We need to be able to upload and store high-resolution images. We need to catalog those images with metadata. We need to be able to pan and zoom inside images and define points of interest and areas of interest. We need to be able to annotate those points of interest with labels and descriptions. We need to be able to index both the image as a whole and also the individual points of interest. And we want to do that, given the context of this exercise, as linked open data. So we're going to use linked open data taxonomies for that. We also wanted to, as part of the learning application, educational application, build audiovisual commentaries that overlay these images and use the points of interest and the annotations in sort of a guided tour format. So we've built some tools to do that. And lastly is the ability to search and browse across image collections. So those are the user requirements. Now before I do design, I'm going to do a mini show and tell live of that. Then I'll go back into some more of the theories and design principles, and then we'll come back for more of an end-to-end experience. But I'd like to just show you a little bit about what we have here. So I've pulled up an image. This image is a painting in the National Gallery in London of Bacchus and Ariadne by Titian. On the left you will see a discovery panel, and in this discovery panel we have got points of interest, and these are figurative details within the image that have been isolated and annotated. So I've clicked on Bacchus, the system pans and zooms into the Bacchus figure. On the left you will see there's a description about Bacchus, and we've got some subject terms, and these subject terms are about that visual detail. They're not metadata sitting on the whole image. These are metadata and indexing that's applied to that particular visual detail. I'll just click on another couple to show you. So these are some cheetahs in the in the painting, and there's an urn down there. And that urn, when it comes in focus now, you can see that that's been signed by the artist. So this is the Latin version for Titian. So visual details of the painting become searchable, they become navigable objects in their own right. Not only that, but each object that's been annotated has its own HTTP URI. So they become first-degree citizens in a linked data environment. I'm going to click on the image tab here, and on the image tab we have just some general metadata about the whole image. You'll notice there's a brief description, title, etc. And we've got a couple of concepts. It's been assigned to the Renaissance as a period of artistic style and to a subject of love. I'm going to go into just need to sign myself in as an editor. 1 second. Right, I'm going to go into this image as an editor now, and I'm going to add a concept about it. So I'm going to go down into the search box and type Bacchus. And do a search. Now what this is searching, that was searching millions of records of linked data. It's searching DBpedia, Getty, icon class, which is an iconography classification scheme, the Library of Congress names, Library of Congress subject headings, etc. I'm going to filter that down into icon class, which is an iconography classification system, rerun that search, and you'll see here some very, very specific concepts in a concept scheme for art iconography. And here there is a concept for what exactly is being described in this in this painting, which is Bacchus finds Ariadne on the island of Naxos. So I'm going to select that concept. If I open that up, you will see this is it. That's a linked data reference to the concept in the icon class classification system. It's got hierarchical associations as well. There are other bits of the image that have already been indexed to it. I'm going to press the tag button, and now I can choose a relationship to tag this painting to that concept in icon class, and my relationship types themselves are linked data, and I'm going to use Dublin Core. So this is DCT, Dublin Core terms, subject, predicate, or relationship type. So I select the DCT subject relationship type and I assign it, and that's now been indexed. So if I go back into non-edit mode and just have a refresh of that. No, it has not taken, but let me I'll have to rerun that. But the assignment process is what I was illustrating there. So the process is to link paintings or images or parts of paintings to the outside world, and the outside world can be any linked data scheme. So here we've got Getty and other. Oh no, we do have it. It's right there. I'm sorry. So that is that's the assignment that we just made. Okay, right. I'm going back into PowerPoint mode now. Let me just go full screen on PowerPoint. So the next little segment is going to talk about the design process. And this is really talking about producing data structures that are based on ontologies. So some of the general principles for the overall system that we've built here is managing the metadata and annotations using W3C linked data standards, storing all the data in a triple store. The images are obviously not textual, but we use a very, very cool new standard called IIIF, which is the International Interoperability Framework. And the IIIF standard is a way of accessing and sharing images over HTTP. I paraphrase IIIF as it's linked data for images. So it's a very cool standard, and we've used that to process our images and provide access to our images. But everything else that you're going to see in the system is basically stored as RDF in a triple store. The general annotation model we're using is again W3C. It was called originally the Open Annotation Model. It's now called the Web Annotation Model, and it's that annotation model that links everything, all the linked data to the images. We are adopting and reusing ontologies as linked open data, and we're adopting and reusing taxonomies as reference resources. So those are our general design principles. This slide has sort of that overall architecture, how we have segmented things into ontologies, knowledge organization systems, images, and the different protocols and open data standards that we're using to support the model. So the next phase of design, after picking the general standards and the environment for a development project, is data modeling. And data modeling begins by taking an inventory of the different types of real-world entities and abstract ideas that need to go into an information system, and basically capturing them, whiteboarding them out, and abstracting them. So in our application, we're dealing with artworks, we're dealing with the people and places associated with those artworks, concepts and illusions that are related to those artworks. So what we need to do in data modeling is abstract those into things that fit in knowledge organization systems. And in that abstraction process, we identify entities and the types of relationship that need to link entities together, and the types of properties that need to go be attached to the entities. As we look at those, we'd say, well, we need a place to store people because there's going to be references to people. We need a place to store information about artworks themselves. We need a place to store geospatial data or place names and so forth, and we need appropriate links, because all links in linked data are semantically expressive. So we can go, for instance, from a person to an artwork through a relationship that says this is the creator of that artwork. We can go from a person to a place to identify their birthplace, or it could be their death place, or it could be a place where they flourished and worked. Places or any other entity can also have sets of properties. Properties are also have types, predicates like relationships, but properties end with a bit of data rather than a pointer to another entity. So in this case, the entity of Florence has properties for the label Florence in English, or Firenze in Italian, its latitude and longitude, etc. So these are the properties that go with a particular entity. Once we've got our knowledge organization schemes whiteboarded out, and we've abstracted the sorts of entities that we need to deal with, the types of relationship that we need to specify, the types of properties that we need to capture, then we can literally start building schemes to store them. And I'm going to illustrate that process in a second. Because we're doing all of this as linked data, we want, as far as possible, to adopt pre-existing schemes, and linked open data ontologies provide a ready-made library of lots of reusable property types and relationship types that we can adopt, so we don't need to build everything from scratch. We can jumpstart our project. Let's see here. I'm just going to start this. This is a canned 1-minute video, and it just runs through one of our other linked data applications. This is an ontology and taxonomy management system called Graphite. And this is just a tool for building ontologies, building taxonomies. And what the screencast is showing is we've got preloaded into this system a set of ontologies, public linked open data ontologies like FOAF, Dublin Core, Geo, OWL, PROV, SKOS, which is of course the Universal Knowledge Organization System for taxonomies. And these ontologies contain properties, relationships, hierarchical relationships, and we can reuse these in all of the relationships we build. And there are two advantages of doing that. One of the advantages is it speeds up the process vastly of designing and building knowledge organization systems. And secondly, it helps because if you share data with anybody else, the structure of your database, the things that define your properties and define your relationships between entities are all in themselves intelligible. You can go and look up what a relationship type means with reference to an external ontology. So there's a lot of advantages to using external linked data ontologies. The next very short segment, this is about 30 seconds, is designing a knowledge organization system. Let me just go back. There we go. Start that little video segment. There we go. So this is, we've got ontologies in the system, and we're going to design a new COS, a new knowledge organization scheme. So here we've got, well, I'm actually going to show you a pre-existing one. This is Scheme Y, and Scheme Y is being built using SKOS. So SKOS is the ontology. What I can do when I build a knowledge organization scheme is I can pick and choose the properties and the relationship types out of different ontologies and build a custom scheme that uses those properties. So ontologies become the building blocks for building knowledge organization schemes. And knowledge organization schemes become the repositories for the different types of entity. So in our model, we said we've got people, places, abstract concepts, artworks, etc. So we would build COS schemes to represent all of those fundamental different types, and we design and build the components of those COS schemes using the building blocks from public ontologies. The next segment is about adopting and reusing open data resources. So when you use taxonomies, one of the first questions is, should we build our own or should we buy it? Or we're going to really look at cases where you don't have to build or buy, you borrow, because those taxonomies in linked open data world are openly available. But the mantra I would propose for anybody looking to do any kind of linked data, any kind of taxonomy project or ontology project is not build or buy. The new mantra is adopt first, adapt second, and create third. So if there's something out there that fits the bill, use it. Number one, it will save you time and money with your project, and number two, you become much more, your data becomes much more intelligible, both internally and certainly if you ever publish outside of your organization, or you mash up your data with the data, additional data coming in from the outside. So adopting is ideal. If you don't have a suitable ontology or knowledge organization system, adapt, make minor modifications, and only when you really don't have anything out there that fits your purpose do you create. So that's how we approach everything today. So let's look at the world of linked open data resources. There are many trusted sources. There are resources from people like the Library of Congress, from Getty Art and Architecture, or the Getty linked open data vocabulary set is now expanding to all of their data sets, so the Kona catalog and the AAT and so forth. DBpedia is also available as linked open data. What we did in the system I'm showing for you today is we ingested 11 million primary concepts or resources and over 130 million relationships and properties. So a lot of data, all of that data came in as linked open data, and it gave us an enormous and rich set of resources to work with as we were building tools to help annotate and index artwork. So lots and lots of stuff out there. Stepping aside from the art use case that I'm using today, if you were trying to think about, well, what does that mean for me in my enterprise, my organization, I'm not going to say that there's linked data for every application available. Domains that tend to work well for adoption are hard sciences and also cultural heritage resources. There's a lot out there that is generally usable and repurposable within an enterprise. So the areas in green here, things, the STEM, science and technology, engineering and so forth, generally those linked open data resources plug and play pretty well in other people's applications. When we get into sort of the middle ground, there are products and services and commodity-based taxonomies and linked data resources, and those two can work reasonably well, although they tend to be a little bit more nationally specific or geo-specific. The things that really don't work well are corporate and enterprise taxonomies, because the language an enterprise speaks tends to be basically a private language. Words take on meanings that only have validity within that enterprise. So, but certainly in the grey area and the green area, there's a lot of material out there that can help you to build and organize your own content. And once you use it, you have a gateway or pathway through to other resources in the outside world, big data resources that you can bring in and help improve the knowledge and intelligence within your enterprise. Right, so I've got a very short screencast here which is going to show you building a designing a brand new concept scheme from scratch. So let me just do that. And this is using all those other schemas. So I'm creating a new concept scheme called Scheme Z, and this is a real-time recording what I did yesterday. And you will see, for me to create a brand new taxonomy based on SKOS using cherry-picking ontology building blocks is going to take about 60 seconds. I'm also saying that this scheme right now, I'm saying the scheme can use the hierarchical broader narrower from SKOS and the related from SKOS. And then lastly what I'm going to do here is I'm going to say I want to be able to do a crosswalk mapping between this brand new scheme Z and scheme Y. So I use, in this case I've chosen to use the OWL same as relationship type to link from from scheme Z to Y. Then the last little screencast in this segment is actually building concepts. Let's jump ahead. Let me just start this one. Again, this is real time, and what I'm going to do in this is I'm going to go to the concept manager and I'm going to start building concepts in Scheme Z. So I type in my first word, which is animals, and build a concept. Then I'm going to build a concept under that, which is mammals. And I'm going to build a concept under that, which is canines. And the last thing I'm going to do is I'm going to explore the other scheme, Scheme Y, and I'll find there's a concept dogs, and I'm going to do a same as relationship from my canines term in Scheme Y to my dogs term in, from my canines term in Scheme Z to my canines term in Scheme Y. So that's built the relationship. So tools like these are what you can use to build your own linked data COS vocabularies where you're not adopting. But as all of the previous slides showed, there is an enormous millions and millions of concepts out there available for reuse. Okay, so we're now going to go into a segment of some live demonstrations. So let me just go back into the system. And I'm going to start off with another image. So in this image, I wanted to illustrate how we can use linked data to build, to look at this visual space. So I've got a lot of points of interest that have already been identified in this space, and we can actually assemble the points of interest into a hierarchy. So I've gone into a hierarchy now, and I can illustrate how we can explore this visual space. We can decompose the visual space into like a table of contents of a book. So you can read the painting a bit like reading a book. So if I press the left panel, it will pan and zoom to that left panel. I can go further inside that panel, and we've got a scene in which God is presenting Eve to Adam. I can go down even further, and there is Adam looking at Eve. Let me collapse that hierarchy of the table of contents. I can go to the right-hand panel. The system pans and zooms to the right-hand panel. There's a figurative detail in this painting called the tree man. We pan and zoom to that. And then we can go and have a look at even a zoom in, very close zoom in of the face of this character. Down here you will see that every visual detail of this painting that's been annotated is itself an HTTP URI. Everything is linked data, everything is sitting inside a triple store. Okay, I'm going to pull out of that painting. I'm going to go into another painting. This is Hans Holbein's The Ambassadors. And in this painting, I've got in the discovery panel, instead of looking at the points of interest, that's the points of interest, visual details on this painting, there's also a button or tab here called concepts. And what I'm looking at here is the ideas, the control vocabulary subject terms behind the visual details that have been indexed inside this painting. So let me take one of them. There's a concept here called fugacity of time. That just means the fleetingness of time. If I open up the concept browser, I can see that this also comes from Icon Class, the art iconography classification scheme. And I can see that there are a number of visual details on this image that are indexed to this concept. So there is a clock. Doesn't look much like a regular clock, but that is a clock. You'll also notice as the system pans and zooms around the image, the tag cloud of concepts is going to dynamically change because this is responding to the visual space. It's telling you these are sparkle queries that are being refined as we move around the image, and they're feeding in coordinate data about the image to determine what are the associated concepts. We've got, that is a calendar, an ancient calendar device, and here is a polyhedral clock. We've also got a lute, and the lute is obviously not a timepiece, but it is conceptually indexed to the fleetingness of time because it has a broken lute string. You can possibly see that, but there is a tiny little, like a hair of a broken string indicating a couple of potential ideas. One is the shortness of life. The general theme of this painting is actually, it's called a memento mori, which is the life is short idea. And that broken string is also potentially indicative of discord between the court of Henry VIII and the French court of the time. But pan and zoom around the image, what we are able to do is explore the concepts that we're looking at in real time through the image. Right, let me have a look here. Let's do a little time check. Yeah, we're doing okay on time. What we're doing here is searches. So I can just do a reset here. So we'll search for time. Okay, so this, I've done a search for time. What we're identifying are both visual details that might be to do with time and also abstract concepts that are to do with time that are related to visual details. And we're getting in our search results. So we've searched across a great deal of data there, but we're identifying not just images, but tiny little details. So you'll see here in this thumbnail here, it's identified in the search results that clock, or it's actually identified those three things that we were looking at in the Holbein painting that are directly related to a concept from iconoclast about time. And we can go and visit the images themselves, or we can visit the whole painting by clicking on the links here. If I do another search, let me search for love as a concept. Okay, so here again we are searching across image collections, and we're discovering both images and visual details within those images that are to do with that particular concept. And because this is conceptual indexing, those results are not necessarily obvious. So if I have a look here, there is a visual detail of a caper flower. Let's see which painting this is in. This is within Bacchus and Ariadne. So I clicked on the concept. It took me to this visual detail, the caper flower. And the caper flower is it's a symbolic allusion to love, and so the painter put that into the painting. This is not obvious, but through image annotation and through conceptual indexing, we're able to discover visual details about ideas just as much as we're able to explore the painting by the visual details as well.
Dave?
Yes?
Sorry to break in. It's come to our attention that the beginning of the webinar started a little bit late, so the audience missed my introduction, and they also missed the part where I said that there is a channel on the right-hand side where you can have where you can put questions, and 15 minutes from now, we'll have a question session, and any questions that you type into that channel I will then pass on to Dave, and if the recording will have the full webinar, including the introduction, including the parts that you missed at the beginning. So I just wanted to say that, and back to you, Dave.
Okay, thank you, Tom. Yeah, if I get to the end of this and I can go back to any missed slides, I will, but I think it only cut in after a couple of slides. So, right, so let's have a look at a couple of other search modalities that we wanted to support in the system. So I've called into screen right now a project that was being run by a university in China, Wuhan University. There's a wonderful series of Buddhist cave temples in China, the Dunhuang cave temples, and these have frescoes depicting many different stories and narratives. The site is on the Silk Route. Now, what the university has been doing with this application is they've been going through these images. Let me just sort of show you. If I turn captions on, you can see they've isolated different figures and different scenes within the figures, and they are describing them both with annotations of the visual details, that's the Panofsky analysis number 1, and also with concepts about them. The other thing that they've done is they've used our guided tours feature. So if I switch to tours and go to the first guided tour, what you can do with guided tours is you can, let's say an image has got, I don't know, 100 points of interest defined on it. You could select 10 of them and put them into a playlist. And we designed this panel here to look a little bit like an iPod playlist. So we can start the guided tour.
古代印度的恒河岸边住着一只美丽的鹿，鹿角洁白如雪，皮毛花纹灿烂。
And what the system is going to do is it's going to walk you through the playlist and automatically pan and zoom from one bit of the image to the next and play any narration. I also have something in English, so I'm going to switch to another site. Let me just go to my other site. Okay, in this site I am looking, we are looking at a Greek figure from the Bryn Mawr College art collection that has been annotated by students at the university. So I'm on the image tab right now on the left, and you can see we've got information, general information about this artifact. And this is, of course, a photograph from above. The object can be, there are other images of the calyx from different positions. We have external links. So this is a link pointing back to the museum catalogue record in the Bryn Mawr online catalogue collection. So we can make links back into external systems. And you'll see some of the subject matter here we've got some Getty AAT concepts that have been applied to the artifact as a whole, and we've got some subject terms. It has a good number of points of interest as well on this image. So if I turn on captions, you can sort of see the areas that have been identified. But in the guided tours, we can go into tours mode here. Now, the interesting thing with guided tours is we can create, as linked data, multiple guided tours, and this gives you the ability to comment on an artwork from different perspectives, to do comparisons between perhaps contending interpretations or different views at different points in time. In this particular case, Bryn Mawr College produced 3 guided tours to look at different aspects of this: conservation aspects, artistic techniques, and the narrative. I'm going to use the narrative one, and I'll just start this going, and then I'll skip to a couple of skip through.
In ancient Greece, the symposium was a drinking party, attended by aristocratic men. Symposia were generally held in the andron, the men's area of the household. The participants, or symposiats, would recline on pillowed couches.
I'm going to flip through.
Although typically,
flip through the playlist.
Participant wears a hymation or cloak wrapped around his waist as he reclines on the couch.
So what we're doing there is the system is going to drive around the image and play whatever the associated media is. You can upload MP3 files, you can upload...
The couches had pillows for the...
Just stop that. You can upload MP3 or MP4. If it's an MP4, it will play a little video in the side panel there. And you can link, so you could link to a YouTube video or resource as well. And so we can do audio-visual commentary on top of annotations inside the image. Okay. Right, I'm going to, there's lots of other things that we could go back to on the visual interactions here, but I'm going to go back to the slideshow, talk a little bit about graph databases, and then I think it'll be about time to revert to Q&A. So let's just see. These are I put this slide in because obviously you don't have the interactivity in your slide download, but I put a slide in here to show some of the different types of functionality that are supported as user experiences. And the fact that all of this stuff is basically triples. Anything that is not an image is basically a triple, and we can describe those triples and share them. This slide gives you that picture of assigning a point of interest to an external resource as linked data using a linked data predicate. And the same thing here, we've basically got that linking out to the Getty AAT concept for love as an association to the Bacchus figure there. Right, just a couple of minutes talking about graph databases, types and performance considerations. I just have to wait for this to paint. Don't like transitions, but okay. So here we've got what triples look like. So basically, a triple is a subject, a predicate, non-object, and that subjects. The subject here is basically a URI that identifies an entity. The predicate is the relationship or the property type. And the object is another entity, or it is a literal, a textual value, or it could be a data type like a date or something. But here we are saying Charles Babbage influenced Ada Lovelace, and that as a triple would result in these if we were to express this using the Library of Congress authorities for those entities. So we can use the triple store to represent these two nodes and that relationship as graph data. Graphs get pretty complex, and you can have lots of different entities related to each other through different semantically expressive relationship types, and it's very much an open graph, an extensible graph, rather different from a relational database. Now let's have a little word about relational databases and graph databases. Certainly my company started before graph databases existed, and so we have lots of relational database products, and they are very good at certain things, but they're not good at pattern matching queries, where graph databases are exceptionally high performance. So with a graph database, we can identify complex queries. We can identify patterns in a way that a relational database will just grind to a halt. So they are very good at certain things. They are not necessarily, graph databases are not necessarily very good at free text searching. They tend, native triple store repositories tend to be rather poor performers when it comes to free text searching. There are ways that you can overcome these problems, and some of the ways that we have experimented with tuning the performance in our application that I've been showing you today, we've done numerous different things. Firstly is external linked data resources like Library of Congress and Getty and even DBpedia. They exist in the outside world, but if you're doing a federated query and hitting many different servers to gather and merge your data into a single query, that itself can be a poor performance. So downloading those resources and caching them into the local server is a very good way to help improve performance. When you cache data from external resources, you need a process to ensure that it is as up-to-date as it needs to be, and that process may be, you know, a synchronization that could be every year or it could be every day. But if you're caching remote data locally, you need to understand what its time sensitivity is and bring that data up to date. Indexing the literal property fields of a graph database using with an integration to a search tool like Apache Solr is another method, and that can work very well. Or there are some triple store databases that have built-in indexing capabilities. The one that we've demonstrated today uses GraphDB from OntoText on the back end, and we like it a lot. It's a very good high-performance graph database. Another technique is to create named graphs. So if you think of the graph database as an enormous, enormous container of entities and connections, what you do when you create named graphs is really define subzones of that graph and give them a name, and entities have membership in those named graphs, and that can really help streamline and tune searches across those graphs. So just those metrics again, in the system that we've been running, we've got 11 million plus entities, 130 million properties and relationships. So when I've done my searches, my keyword searches and so on, they're running essentially against tens of millions of entities. We have attained sub-second search time on simple searches, and multi-word phrases tend to be in the 1 to 5 second range. Decent. I'm not saying that's, you know, it's a benchmark. Every enterprise will need to set its own standards for that, and there's lots of work that can always be done to tune indexes. Okay, RDF or not to RDF. There are graph databases that are not RDF, and there are some really good databases that are not RDF, like Neo4j, which is a very gaining lots and lots of customers. We like Neo4j, and we worked in Neo4j. However, for linked open data, we believe RDF is essential. It is essential to the process of sharing data and using data. Now, in some of the non-RDF databases, you can, including Neo4j, you can reference and pull in and export to RDF, but there are other databases that are native format RDF. There was a very good article recently published that did a review of the pros and cons of building in RDF or not. And the link is in the slides here, the ZDNet article. I'd recommend you go and look at that. It's a very good balanced discourse on the subject. And it is a complex set of pros and cons. This is my favorite linked open data books. Again, the slides are there for your reference. Also, if you want to have a look at some of the linked Canvas arts application, we've got some tutorials and videos and further information at linkcanvas.org. And another resource on linked data is produced by Dublin Core, sponsors of this webinar. And thank you, Dublin Core, both for hosting and sponsoring this webinar, and giving me a chance to show you some of the things we're doing. I'd like to plug an effort by Dublin Core, which is called Linked Data for Professional Education, LD4PE, and there's a URL here. What they have created here, this initiative, is building a set of resources all about linked data. So fundamentals of linked data, working with RDF vocabularies, transforming data transforms, etc. So this place has lots and lots of really cool reference material. It's produced by a Dublin Core. Synaptica had a small contributory role to this, but a lot of smart people have been working on putting this resource together. And that brings me to the end, and handing over to Tom for any of the Q&A that's come in.
Thank you very much, Dave. So you're all invited. We have about 10 minutes to answer some questions. And so you're welcome to type your questions into the chat channel. The first question is the following. Is the linked data used outside of the software? Is it shared on the web and findable on Google, for example?
Okay, so this is the linked data in linkedcanvas.org. I'm going to assume that is the question. Linkedcanvas.org, the examples that I've shown you are not all accessible through Google. In fact, very little will be. The data, for instance, the Wuhan University data set, the Bryn Mawr College data set, those have been produced as sort of pilot studies by those universities, by their students, and that data is sort of their data and private. The general principle of the application is that it can be designed for producing content that can be shared. I mean, one of the like I said in one of the slides, there's linked open data and there's linked enterprise data. The decision to publish is every individual organization's decision. We passionately believe in open data and technologies that support open data. The specific examples we've provided are other people's work. So we're not free to show those ourselves.
Okay. We have another question here. What would you say is the biggest barrier slowing the wide adoption of linked data?
Good question. I think that linked data, let me just backtrack one of those slides there. I think working with RDF is undoubtedly much more complex than some other systems. So it's more complex than working with, tables and relational databases, and it's more complex than some of the non-RDF graph databases like Neo4j. So, if you take the arguments, and I really do think this is a great article to go to relevant to this the second question that's come in, is you'll see some of the pros and cons of using RDF and linked data or not. I think the barrier is the complexity. The benefit is the application I've shown you, panning around images, annotating images using DBpedia and Getty and all these other resources. All of that stuff we could access as open data. We could download it, we could ingest it, we could reference it through Sparkle endpoints. So there's a wealth of resources available to enrich projects. There is a benefit from using linked data. But the hurdle, I think, is the complexity. Now, I mean, what I hope, my company, obviously, we're a software developer, is that software developers like ourselves, and there are other great companies out there doing good work in this field, provide tools to make it easy for you to do that, to make it easy to get over that hurdle of having to learn about RDF and linked data. So we've tried, I mean, I showed you building a knowledge organization system based on external ontologies and basically creating terms in 2 minutes. So we and other people have provided tools that make it easy to do linked data, because you don't need to learn all of that stuff that's going on in the background. It's user interface driven, but I think the hurdle is the complexity. If you just sit down and try and learn RDF and graph databases from scratch, it is a barrier.
Okay, we have exactly 5 minutes and then we need to wrap up. So what I'll do is I'll sort of summarize some of the questions here, and then you can choose which one to answer, and then let people know how they can get answers to the other ones. So one question is specifically about managing the minting of URIs, such as for resources such as portions of images. In order for them to be stable, they shouldn't change. If they are under your domain, do you have a commitment to maintaining their stability? Alternatively, how does the software support the minting of URIs under a user's domain name? Another question we have is, can you share some of the technical experiences of going from a relational database to a graph database? And then we have 2 very specific questions on the pricing model for linked canvas and how can we try out the Graphite tool. So with just 4 minutes to go, I'll let you summarize handle which ones you can, and let people know how they can get information on the others.
Okay, great. First question was managing the minting of URIs. So the domain names, namespaces used in any of the demos that we have done are basically our own domain names for the purpose of building applications to show and tell. Anybody who uses our software would plug in their namespaces, their domains, and they would be able then to control, the persistence of their URIs. So it's a good question, but URIs and the base domains that are used for those are entirely, entirely assignable, or you could use third-party permanent tools like Pearls to create permanent URIs. The experience of going from relational to graph database, I would say it was, just a sea change. We still have our relational database-driven products, the Synaptica suite, and those will be maintained for, an untold number of years to come, because relational databases aren't going away. They do certain things really, really well. In parallel to those, we've created graph database solutions. But we see maintaining relational and graph database solutions for the next N years. I don't know how long. We have no plans to move away from relational. But the journey from relational to graph was a big one for us, but we had to design everything from scratch to work with that. We had to face all those challenges of how do you get graph databases to work really, really quickly, to give you, a second or sub-second response when you've got tens of millions of entities in the graph database. So these challenges are ones that I really can't talk about if I'm going to cover the other couple of questions further. But there are URLs for Synaptica on screen, and there's actually my email down there, and our graph designer, Gene Lowe, down there as well. So make a note of those, or they'll be in the slide. You can contact either of us separately. Pricing, our website, linkcanvas.org, has some institutional pricing for people who want to try linked canvas as an educational tool in universities or colleges. and that's a non-profit price model. Our other software basically just get in touch with us. The graphite application that I've demonstrated is going to beta, so that is not licensable yet, but it will be licensable within I would say a couple of months. So that is a new product development that's coming through the chute. We are interested to connect with companies or institutions that have that could be a beta site for that. So if you are interested, do get in touch. Did I cover all those 4 questions, Tom?
Yeah, that's perfect. So I think we've reached the end of our time, and I want to thank you very much, Dave, for this really great talk. The slides will be available. There will be a link to the recording that will be sent out to all of the attendees, all the people who registered for the webinar by email. So you'll have a chance to re-watch parts of the entire thing or parts of it. And so with that, Vanessa, do you have any further announcements to make? Okay, if not, then thank you all. Thank you all for coming. Thank you, Dave, for presenting. And look to your email for the link to the recording.
Thank you very much, Tom and Vanessa and ASIST and Dublin Core for this opportunity.
Thank you.